Today's lesson is on solving inequalities using multiplication and division. The directions say to solve the inequality. So similar to how we solve an equation, I'm going to isolate the variable in these inequalities. So in number 1, I have 21 is less than 7x. So I have 7 times x, so I need to do the opposite operation, so I'm going to divide. I will divide both sides by 7, and I have 3 is less than x. Now, as we stated earlier, it's easier to graph if we have our variable on the left-hand side, so we're just going to get into practice of rewriting it. So I have x is greater than 3. In my original inequality, the arrow is pointing to the 3, and in my new inequality, my arrow is still pointing to the 3. In number 2, I have 4x is greater than 10. So again, there's my wall. I have 4 times x, so I'm going to do the opposite operation, which is divide. And I have x is greater than 10 over 4. Now I can simplify that to x is greater than 5 over 2. In number 3, I have 2/3 x is greater than negative 10. So I have 2/3 times x. So if I want, I could divide both sides by 2/3, or I could also multiply by the reciprocal, which I'm going to do here to give us more practice with that. So the reciprocal of 2 over 3 is 3 over 2. Whatever I do to one side, I have to do the other side. So on my left-hand side of my wall, this will simplify to 1, so I have x is greater than, and negative 10 times 3 gives me negative 30 divided by 2. So that will simplify to x is greater than negative 15. Now we're going to work with something that we haven't done before. This is a new rule. When you multiply or divide by a negative number, so I'm multiplying or dividing by a negative number, you must change the direction of the sign. So in looking at number 4, I have negative 16 is greater than negative 2x. There's my wall. In order to isolate the variable, I need to divide both sides by negative 2. And when I do that, because of this negative 2, because I divided by a negative number, I have to change the direction of the sign. So this greater than sign right here becomes less than. So I get negative 16 divided by negative 2 is positive 8. On the left-hand side, I have x. Now again, as we've talked about before, I'm going to rewrite this so my variables on the left. So I have x is greater than 8. That's my final answer there. So again, the biggest thing is I divided by a negative number. My original inequality was greater than, and that had to change to less than because of that dividing by the negative number. In number 5, I have negative x divided by 6 is greater than or equal to 5. So again, I need to isolate my variable, so I'm actually going to multiply both sides by negative 6 because that will give me a positive x on the left-hand side. Because I'm multiplying by a negative number, I'm going to change the direction of the sign. I'm going to do that right away just so I don't forget. So my 6's will simplify, so I get a negative times a negative, which is a positive, so I have x by itself on the left-hand side, and 5 times negative 6 gives me negative 30. So my final answer there is x is less than or equal to negative 30. Number 6, I have negative 4/5 x is less than or equal to 8. Now again, I could divide by negative 4/5, but I don't want to use my calculator, so I'm just going to multiply by the reciprocal, which we've done before, and that way I can just do it quickly and not have to get my calculator out. So on the left-hand side, my negative 4's will simplify, my 5 will simplify, so I'm left with x. But I have to remember to change the direction of the sign because I did multiply by a negative number. On the right-hand side, I'm left with 40 divided by negative 4. So I have x is greater than or equal to negative 10. In the last problem, I have negative 15 is less than negative 12x. So I'm going to isolate my variable, divide both sides by negative 12, divided by a negative number. I'm going to change the direction of the sign. I have a negative 15 over negative 12, so that gives me a positive. 15 over 12 is greater than x. Now, I can simplify 15 over 12. They're both divisible by 3, so that leaves me 5 over 4 is greater than x. And again, I want my x on the left-hand side, so I have x is less than 5/4. And that's my final answer. In our last set of problems today, we have some word problems. So the first one says Mario purchases a prepaid phone plan for $50. So that's the most he can spend is $50 at 0.13, which is 13 cents per minute. How many minutes can Mario talk on this plan? So I'm going to take 0.13 because that's 13 cents a minute, multiply that by m, which is the number of minutes. And again, I know that he can spend 50, but he can't spend more than 50 because that's how much the plan cost. So I have 0.13m is less than or equal to 50. So again, I'm going to isolate my variable, and I get 0.13 And then when I use my calculator, I have m is less than 384.6. Now this is a word problem, so I have to figure out exactly what it's asking and do I need to round or what do I need to do to finish up and answer the question. It says, how many minutes can Mario talk on his plan? Well, it looks like he can definitely talk 384. I'm a little bit over 384 at 384.6, but I can't talk 385. He wouldn't have enough money for that. So my final answer, and again, it's a word problem, so I'm going to write a sentence. So I have Mario can talk at most, and like we talked about, we can only go up to 384 minutes. He doesn't have enough for 385. So he can talk at most 384 minutes. Now, in looking at number 2, it says Roger needs at least $560 to pay for his spring break expenses. He is saving $25 from each of his weekly paychecks. How long will it be before he can pay for this trip? So let's see how this goes. So he has $25 per week. I'm going to use the letter W to simplify the number of weeks. And for every week that goes by, he's spending $25. But he needs at least $560. So at least $560. It's okay to have more than $560. I can't have less than $560. Otherwise, Roger's not going to have enough for his trip. So now I'm going to isolate the variable, divide both sides by 25, and I have W is greater than or equal to 22.4. Now again, similar to the last problem, it's a word problem, so I have to figure out what I'm going to do with that decimal. So it says he has to work at least 22.4 weeks. He gets a weekly paycheck. He doesn't get a daily paycheck, so we're going to have to work whole weeks. It looks like 22 weeks is not going to be enough because he'd have to work 22.4 weeks. So it looks like 23 is really what his goal is. So we're going to say Roger must work at least 23 weeks, because again, 22 weeks isn't going to be enough. He's going to have to work at least 23 weeks before he can pay for the trip.